Hello, and welcome back to the video lecture series for Introduction to ER Programming using Scala. We've been looking at polymorphism and specifically inheritance for the last few videos, and we have been playing with kind of a little toy example of shapes. In this video, I want to take and extend the ideas of inheritance to the project that we had started talking about previously. And so I'll remind you that the project was this electronic classroom project. We were going to have a client and a server, both of which had needed to have some main methods, and we had started mapping out some of these things. But I stopped a little bit shy fairly early on of taking this very far because I said that there were just certain things that we needed to know before we could go much further with it. Well, one of the main things that we needed to know was inheritance. So, for example, when you look at this, you might start to notice that there are some things that are kind of good examples of subtyping relationships. For example, students and instructors, well, those are both really subtypes of a more general type called a user. Whoa. Okay. And inevitably, many of the things that we have down in here, in fact, when you start to see stuff like this where you have lots of common fields between types, that probably means that there is a reasonable supertype. So we come into here and let's see, username. Well, both the student and the instructor have a username, a normal name, a password, an ID. And so it would make sense then to just put all of those up here inside of the supertype and to make it so that, scroll up a little bit, so that both the student and the instructor inherit from the user. There we go. So that type of configuration makes sense, and once we have that, we can potentially take this data out of here. And in addition, there might be other functionality that we decide that we need inside of students and instructors. If it just belongs in one or the other, we'd put it in that class. If it belongs in both, we put it up in user. Another example of where inheritance could be useful in here is this, the quiz, the test, the exercise. These really should have kind of a common supertype of the activities that you can do inside of a class or inside of a course, the things that are going to be graded. So an activity, and we can think about what would go inside of there. I'm going to shorten that a little bit and connect it to each of these three. Okay. And then, of course, then a course needs to have activities in it. And using what we have before, we could make this so that it's a list that we will be adding things onto. And, oops, that was not what I wanted to do. Connect that to that, and have it be composition. Okay, so this kind of fleshes out our diagram a little bit. We'd still have to think about some things. So for example, what about the activities? Well, things that would be associated with activities, you should be able to ask what the grade was. And in fact, for grade, using Scala here, this could work very nicely as an option of double, because maybe you haven't graded something yet. In fact, things will be turned in and not be graded. The option allows you to specify that there is a none for the grade, so that it can say that it's not graded. There might be some desire to have a status on activities. So, for example, things that students turn in. I can think of quite a few things that we might decide that are associated with all of the different activities that we want to have for our courses, and they could all go inside of activity, and then the things that would be different are the things that come down into those subclasses. And so just to finish fleshing that out, we can go ahead and put that inside of, stub out some of the classes. We can make a class for a user, and our user, this is where we could think a little bit. So our user had a username, a name, a password, and an ID. Username, string, name, string, password, string, ID, string. I'm actually quite happy to have the username be a public val, the regular name. Depending upon how this is set up, I am in general going to make all vars private. And so the thing is, I can see that when you enter the name for a user, or when you create a new user, you'll almost certainly provide a username. People need to be allowed to change their passwords, but they don't necessarily need to be able to change their IDs. So when you create a user, they will need to be given their username and their ID, and that will be fixed permanently. The name and the password might be things that are added later, and they could either be given a default value or whatnot. And then we would have some different subtypes of this in the form of a student and student, at least for now. I'll make it so it extends the name with the username, and oops, not the name. The way this is written right now, okay, and a local value for the ID. I'm not going to make these vals vars because I don't want to remember them. Their values are being stored in the super type of the user. Methods that might be useful that could also go inside of here would be check password, takes a string, returns a Boolean that is lowercase p, checks to make sure that what was passed in is equivalent to the password. We would need methods for setting names and setting passwords. Notice I'm not actually going to provide the ability to get back a password, because if you for security reasons, I don't want the password to ever leave this class. This will be private here, and all of the methods that interact with it will interact with it here inside of the user to improve the security of the application. We could also have our activity, super type, and the only thing that we had thought of to put in this right now was our grade, which is an option. Actually, let's see. I can see this not being passed in. Actually, no, I probably will need it to be passed in. We'll hopefully come to talk about this at some point in the not too distant future. Should something like this be passed in, or should it be declared as a val or a var inside? And you might have noticed that in general, I almost always default to passing things in. And the reason for this is associated with what happens when, for example, you want to save these things out to file and then load them back in. Well, when you load back in an activity, so when you first create an activity at the very beginning of you're running your GUI and you just set one up, it might be fine for it to only have just the grade. Hey, you know what? Activities need names too. And the name of the activity is going to be variable. The grade is also going to be variable. And that is now getting long enough that I want to space it out. Okay. The reason to pass everything in is because even though when you first create an activity it might be fine if it doesn't have all those values, if I load one in from a file, okay, so if I've written out the data for an activity into a file, maybe it's in an XML file, maybe it's in just a standard file, when I go to read that back in, I need to be able to create an activity that has all the data that was saved off to the file. And one way to do that would be to create an activity that has less of the data and then set all of those values. But in many ways that's less than ideal. It really is nice if you can make it so that all of the things that need to be, all the values that are needed to set something up, anything that isn't like temporary storage, can be passed in to start with, and that way you can build these things easily when you load them back in from file. We'll actually see that as part of the activity, because one of the things that this needs to be able to do in our program is to have it so that you can save stuff off the file and load it back in. And I'm only going to take time in this video to create one more subclass of this. We'll call it our quiz. And it will extend an activity with that name and none, because it starts off where the grade, well, there isn't a grade to start off with. So just wanted to show you the beginnings of how inheritance might play a role in this project. We'll come back to this later. Hopefully you're also starting to see how these UML class diagrams, once again, it's not just a collection of boxes. The lines between things really start to show you some of the structure, and there really are a lot of lines connecting different things in this figure. So we'll continue working on this. We actually need to set up kind of the code for this, and I'll probably generate a series of videos. Probably have to do a little bit of the coding offline, just because you don't necessarily want to see me write every single line of code that goes into this. Some of them might be a little bit redundant or whatnot. But we'll come back and we will continue to work on things, and we'll also look in one of the videos shortly at the idea of parametric polymorphism, a different way for us to get universal polymorphism. So that's it for now. See you again soon.